Here, next topic is resonance. Before going to discuss about this one, I will discuss some points. That is CH4. If you take this molecule, what is its structure? CH H H H. This is the structure, tetrahedral shape. Next, one more structure, NH3. Its structure is NH. It is pyramidal shape. H2O. It is having two lone pairs of electrons. This is angular shape. But when you consider this structure, SO4 minus 2, its structure is, what is its structure? Tetrahedral. How can we say that? By using this formula, P equal to G plus M minus E by 2. So here G value how much? G means what? Group number of the central atom. How much? 6 plus monovalent atoms 0, because oxygen should not consider as monovalent. Here charge is minus 2. Minus of minus 2 plus 2 by 2. That means 6 plus 2 by 2. That means 8 by 2. So 4. If 4 comes, that is what? sp3. Then how many number of lone pairs? P minus number of surrounding atoms. That means 4 minus 4. That is 0. So sp3 with 0 lone pair. What is its shape? Tetrahedral. So its shape is like this. SO4 minus 2. That means this one. Here you can observe one more structure. Here you can observe that one more structure will come. That is double bond O minus double bond O minus. See, here double bond O is present here. Here also double bond O is present. But here double bond is present left side. But here double bond is present in central. Here one more structure may come. That is O minus double bond O. This is also this is also one of the structure. If you observe these structures, what is the point? For SO4 minus 2, there is no specific structure. It has so many structures. In all the structures, position of atoms are same. See, in all cases, sulfur is present at a center. Oxygens are present around the sulfur. There is no change in their position of atoms, but there is a change in position of bonds and charges. Position of bonds and charges. Such type of structures are called resonance structures or canonical structure. So what is the definition for resonance? See here. The existence of a molecule having more than one structure. If a molecule having more than one structure, then that molecule is then that structure is called what? Resonance structure or canonical structure. This phenomenon is called what? Resonance. Here there are some more points regarding resonance. They are, see, this is benzene. This is also benzene. Both are benzenes. In both cases, 3 pi bonds are present. 1, 2, 3. Here also 3 pi bonds. But what is the difference? Position of pi bonds. So these two structures are considered as what? Resonance structures for what? Benzene. If you combine these two structures, then we get one structure, that is this one. How it will be obtained? By combining pi bonds of two structures. By combining pi bonds of two structures, then we get one more structure. How can we combine? See, in first structure, double bond is present here. In second structure, double bond is present here. In first structure, double bond is present here. In second structure, double bond is present here. In first structure double bond is present here, in second structure double bond is present here. If you combine these dots you get this structure. So this is what resonance hybrid of benzene. So what is the definition here? The structure which is obtained by combining all resonance structures. The structure which is obtained by combining all resonance structures is called resonance hybrid. Next, here one more important point, that is bond order. Just now I discussed already. What is bond order? In previous video we discussed it. Between two atoms, how many bonds are present, that the number of bonds is considered as bond order. But in this case, if you consider this structure, between these two atoms, between these two carbon atoms, two bonds are present. But if you consider this structure, between these two atoms, one bond is present. Then what about bond order here? 2 or 1? We can't say exactly. In such cases, in which cases? In resonance structures. In resonance structure, to calculate bond order, we have to use one formula. That is, number of bonds around the central atom whole divided by number of surrounding atoms. Number of bonds around the central atom whole divided by number of surrounding atom. That is one formula. One more formula is there to calculate bond order in case of resonance structures. That is, number of bonds between any two atoms in all resonance structures by number of resonance structures. Number of bonds between any two atoms in all resonance structures by number of resonance structures. For example, if you consider benzene having two resonance structures, use this formula to calculate bond order in case of benzene. Between two atoms here, how many bonds? 2. Here, between two atoms, how many bonds? 1. So what is the formula? Number of bonds between any two atoms in all resonance structures. Here 2, here 1. 2 plus 1 total 3. 3 by number of resonance structures, how much? 2. 3 by 2, how much? 1.5. So the bond order of benzene is how much? 1.5. That is very, very important. Next, one more example. Carbonate ion. What is the formula? CO3 minus 2. For this carbonate, it has having more than one structure. So these are resonance structures. What is bond order in that case? You can apply either of the formula. CO3. Take first formula. What is the first formula? Number of bonds around the central atom by number of surrounding atoms. Number of bonds around the central atom by number of surrounding atoms. If you take any one structure, how many number of bonds around central atom? This is central atom. 2, 1, 1. Total 4. 4 by number of surrounding atoms. 1, 2, 3. 4 by 3. Total 1.33. So this is what? Bond order of what? Carbonate ion. Or if you consider second formula. What is second formula? Number of bonds between any two atoms in all structures by number of resonance structures. Now I consider number of bonds between these two atoms. Here 1 bond, here 2, here 1. Total 1 plus 2 plus 1, total 4. By number of resonance structures 3. 4 by 3, 1.33. So that is the way to calculate bond order of resonance structure. So this is all about what? Bond order of resonance structures. One more example, MnO4 minus. MnO4 minus. In that MnO4 minus, these are the resonance structures. So how many bonds around the central atom? 2 plus 2 plus 2 plus 1. Total 7. By how many surroundings? 4. 7 by 4, how much? 1.75. That means in case of MnO4 minus, bond order is what? 1.75. So that is the way to calculate bond order in case of resonance structures. This is all about resonance. This is very, very important concept. You may get questions regarding this one for 1 mark or 2 marks. Thank you.